is we are, so we're going to now focus on something important, and that is our, so we talked about the merge sorting, and now we will talk about the quick sort. So as a developer, go behind the scenes of understanding of this, and that way you will have a lot of clarities. Okay. So quick sort is all about also divide and conquer algorithm. You can pick a pivot and yeah. So then the partitions that array, you can partition that array into elements also that can be less than and greater than, and recursively you can apply the same logic to the sub arrays. So in the quick sort, we will use the last element as a pivot. So that is important. Okay. So that when you are doing a quick sort, we will take the last element as a pivot, and then we will try to, you can try to do that how you want to add it. It's that value is less than or greater than, you can figure out. Okay. So for that, I would like to do an implementation. So you can go here. One second, go to the quick sort. So when you are implementing each of the sorting algorithms, I was just being asked by many of the coders here. When nowadays most of the interviewers are very smart guys, so they are not just asking you the solution of the problem. They are trying to ask so how it is working, and also they'll ask how this code you have written this works. So someone will ask you this code, what is happening in this code, what is this code is actually doing. So I was just actually, when you say quick sort or any sort, if you look at this guy, I just pass this guy. So what I do is I try to pass this value. So this will take length of this, and then it takes the last element as pivot, and it will check whether that any value from that things will check whether it is less than the pivot or copy it left side or right side. So element less than pivot, go to left, right, greater than, you go to right. Now, the logic is easy, but they'll ask you this, what is happening? What is this code? What are you doing in this code? Can anyone tell me what this code is all about? And what does that means? Can anyone tell me this kind of code base? So can anyone tell me this internals? What is this code doing? Can anyone tell? So why do you write this code? Any understanding anyone has got? Okay, I will talk about that first. Clarity we need to get on this. Suppose if I create a list, that is called list compression. Suppose I have a list here that has a value 1, 2, 3, 4, 5. Okay. If you want to access it, the list values, you write like this for I in list. Okay. And suppose you want to search for something, here you have something like this. Now let's say if I write if I is, maybe I'll specify if it is I is less than, or maybe I'll try to search for 3. Okay, and I'll print that, or I can do whatever it is. I'll just print that value, or I can print that value. Okay, I can print it, or I can store that value into another thing. So the outcome of this iteration is that I'll be able to loop all the iterations, but I'll only get into this condition and access this. That's what I'm trying to do here. Okay, or what I can tend to do is I can actually do this simple code in another way. That is called list compression. So in this case, what happens? You just see this code. Okay. Because they're going to ask you more questions on this aspects. Okay. So to all the smiling coders, you will get an output print 3 there. Okay. Now the question is, where is 3 stored? 3 is not stored. Actually, you are just printing the value. So in this case, what happened? You access the value of I, and still I has that value. That's it. And you printed that. But suppose if I write like this, I write a list bracket. Inside this, let me write down this code. So let me remove this for I in list. So what they have done the same thing. Okay. And then the condition. So specify this. So if this condition is getting true, so what you have done here, you print the value of I. So what I do is, I will not print the value of I. I'll copy the value of I into another list. Remember this. They will ask you this question in interview. They'll ask you what am I doing here? If I'll traverse the list, if the value in the list is 3, I will copy the value of this I into another list. So this is what they'll ask you in interview. So they'll not ask you, they know that because everybody now tries to even try to understand. Some people are trying to focus more on remembering that, recalling it very fast to write a logic. So what we are doing is I is now copied into new list. So now the new list name is, the new list variable name is this guy, and that has I. So now you print it. Print your new list and run this. So you will get a new list. So the interviewer will ask you the question, what is the difference between this approach of looping and this approach of loading? And please be thorough on this, because now everyone consistently practice lead code daily and writes code, and everybody is able to solve it. But now the questionnaire is that they're going to ask you the outcome of it, how does it work, what's the best way. It means we need to understand what's the accessing approach we are doing, and how are we trying to basically access the memory, and what outcome are we doing, what are the other alternate ways we are doing. This is something that is very important. So even in the quick start also, you are just checking. If it is less than, you copy to the left, or if it is right, you are copying it to right, and then you will access this. Okay, I hope this is clear. So coming something like this, lot of interesting will come for you upcoming also. But as I said, that quick start is always that it takes the last element, and then it goes and checks, and then if it is less than, it copies to that and right there, and then it adds the final thing and sort it. Okay, so you can see this. It is taking you the pivot value, and then you will get 3762, because it's going to take that pivot as this, and then you get this, and then you are going to do this kind of transformations. Okay, so now we are coming to the actual part, that is your top 5 DSA patterns. Okay, I have only thought about 3 important things. One is how to allocate memory, how to access memory, and then I've talked about 1 linear search, and 2 sorting techniques I've thought about. I have thought about little bit of internals behind the scenes, what's happening and how we are working with. Okay, now we are going to now go a little behind the scenes and then understand something very crazy. And what is that? I'm going to talk about